So in this video, we're going to learn the concept of electric potential. So let's begin. So see guys, initially what we do is we basically take a sphere of positive charge, right? So this over here is a sphere made up of positive charges. So we have a positively charged sphere over here. Next what we do is we place another positive charge over here. So see guys, we have two positively charged objects over here. Now these are like charges. So what happens to like charges? Like charges tend to repel each other. That means the natural force on this charge will be towards the right. That is, this ball over here will be repelling that charge. Is this clear? Now what we intend to do guys is we intend to take the charge from here and bring it close over here. So let's say this over here is point A. I want to move the charge from point A to point B. So what do we have to do? In order to move something, we have to apply a force. So let's apply a force. So basically, we'll apply a force in this direction. Why this direction? Because this charge will repel it, right? So to bring it close, we'll basically apply a force in this direction. Next, as we move the charge from point A to point B, there is certain displacement. So this over here is the displacement. Right guys? Now, when we apply a force and there is displacement, which physical quantity are we talking about? Very good. Work done. Recall guys, what is work done? Force into displacement. That means whenever we are moving a charge from a point A to a point B, certain amount of work is done. This work done per unit charge is the potential at point B. As simple as that. I repeat, the electric potential at point B is how much work you have done in moving a charge from A to B divided by the quantity of charge. So see, we say electric potential, the symbol for electric potential guys is V. So we say the electric potential at any point is nothing but the work done divided by how much charge you have moved. What I mean is, let's say the work done in this case was 20 joules. I repeat, let us assume in this case the work done was 20 joules and let's say this charge was 2 coulombs. Okay. So what is the potential at B? The potential at B is work done per unit charge, that is 20 joules, divide by 2, that is 10. Is this clear? Now what is the unit of electric potential? Volts. So we say it is 10 volts. That means the potential at point B is 10 volts. I repeat, let us assume 20 joules of work was done in moving this charge from here to here. So 20 divided by, what is this charge? Let's say this charge over here was 2 coulombs. So 20 divided by 2. So we say the potential at point B is nothing but 10 volts. As simple as that. Is this clear? So here guys, what is V? V is electric potential. The unit is volts. W over here is work done. Work done should always be taken in joules. And Q over here is charge. As a unit of charge, that is coulomb. So this is how you calculate electric potential at any point. In case this is not clear guys, I'll mention over here. W over here is work done. Alright. And Q over here is the charge. So this is how you calculate electric potential at any point. Now let's say from point A, you move the charge to point C. Again, what would you have done? Basically, you would have applied a force. So you would apply a force in this direction and there would be certain displacement over here. So again, some work is done. So let's say moving a charge from A to C. In this case, the work done was only 10 joules. Why? It is closer now as compared to B. So we'll find the potential at C. So we say potential at C, at this point C, is the work done per unit charge. So what is the work done? It is 10 joules. Divide by, what is the amount of charge I'm playing around with? 2 coulombs. So 10 divided by 2, that is 5. And what is the unit? Volts. So 5 volts. That means the potential at point C is 5 volts. So I'll write it down over here. That is potential at C is basically 5 volts. So guys, this is how you calculate the electric potential at any point. It is nothing but the work you are doing in moving a charge from one point to the other. So this is how you calculate electric potential at any point. Is this clear? Now guys, a more commonly used term is potential difference. So let's talk about that as well. So see guys, what is the concept of potential difference? So see, the potential difference, let's say I want to calculate the potential difference between B and C. So we want the potential difference between B and C. It is very simple. It is potential at B minus potential at C. So simple, right? So let's plug in the values. What is potential at B? It is 10 volts minus potential at C, that is 5 volts. So we get potential difference between B, C, 10 minus 5, that is 5 volts. So this is how you calculate potential difference. As the name suggests, potential difference. Just subtract the potentials at the 2 points. So potential difference between B and C is 5 volts. Is this clear? So this over here is the concept of electric potential and potential difference. I repeat guys, what is electric potential at any point? It is the work done in moving a unit charge from infinity to a point. So potential is nothing but W divided by Q. Remember, always take W in joules and Q in coulombs. So for example, we had a 2 coulombs of charge here. When we moved it from A to B, right, the work done was 20 joules. So what is the potential at B? Work done by the charge, it is 10 volts. When we move the same 2 coulombs of charge from A to C, the work done was only 10 joules. So what is potential over here? 10 divided by 2, that is 5 volts. And what is the potential difference between B and C? Potential at B minus potential at C. 10 minus 5, that is 5 volts. Is this clear? So this over here is the concept of electric potential and potential difference.